question 2. Gonna start with question 2 because we have already done question 1. So let's go straight to question 2. This is question 2, 2.1. Prove that in any arithmetic series in which the first term is a and whose the constant different is d, the sum of the first n term is Sn is equal to n divided by 2 all into 2a plus n minus 1 all into d. Therefore 2.2, calculate the value of the sum of 50 terms when you start k is equal to 100 minus 3k. 2.3, you say that a quadratic sequence is defined with the following properties. T2 minus T3 is equal to 7. 2t minus T1 is equal to 7. 2-3 minus T2 is equal to 13. T4 minus T3 is equal to 19. 2.3.1, write down the value of A, T5 minus T4, B, T70 minus T69. 2.3.2, you say that we have to write down the value of T69 if T89 is equal to 23,594. So let's start to find the solution for this question. Find the solution. Okay, in 2.1 they said we have to prove that the sum, the Sn is equal to n divided by 2. We have to prove that the sum Sn is equal to 2n divided by 2 all into 2a plus n minus 1 d all into. So we know that this is an arithmetic sequence. This is the sum of the arithmetic sequence. To prove the sum of the arithmetic sequence, you know you have to add all the terms occurred in that series. So let's start. The sum of the arithmetic sequence is equal to the first term. We call the first term is a. To find the second term, you say a plus d to go to the second term. Say a plus d, go to the third term, you say a plus 2d. So now we have 2d, we have to add 2d. This is the third term, plus dot until to the last term, the general formula that you know of the arithmetic sequence, which is a plus all into n minus 1 d times by d. This is the general formula until to the last term that we call Tn. So when you add this, when you add all the sum of this arithmetic sequence, you get this formula. But we have to show that how do we get that formula. So Sn is equal to, you start with the last term, start with that last term and come back up until to the first term. It's the same thing. The first equation. This is the first equation. So let's do the second equation. Will be a plus what the last term? A plus the general formula, a plus n minus 1 d. This is the first term. This is T1 and this is T1. This is T1. This one plus come back to the, when you go back from this term up going back, you will find a all into a plus all into n minus 2 because negative 1 is greater than negative 2. Close the bracket d plus dot 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 up until you reach the what? Up until you reach the first term. Up until you reach the first term, which is a plus what? Plus a. Okay, plus a. So we have to add the equation, the first equation with the second equation. Sn is equal to this equation, Sn this is equation 1, and also this is equation, or this is equation 2. So we have to add the two equations. So when you add Sn plus Sn, give us what? 2n is equal to, therefore add the first term. Just choose any terms that you want to add, but when you add the first terms, we have to add the first terms only. When you add the second terms, you have to add the second terms only. This is the second term, and also the second term start here. This is the second term from the second equation, and this is the first term from the first equation. This is the first term, the second equation. So we have to add both equation, a, which means a from the equation 1 plus the first term from the equation to the equation 2, then plus a, let's say plus a, and all into a plus all into n minus 1 d. So 2n is equal to a, 2a, a plus a is 2a, plus all into n minus 1 d. Therefore 2n is equal to, not 2n, sum therefore divided, you're gonna put this is put bracket here and bracket here, because this stands for the nth term. We're gonna say n all into 2a and 2a plus n minus 1 d, 2a minus 1 d, divided by 2, both terms divided by 2, then you find Sn is equal to n divided by 2, the 2 from that side, open the brackets, 2a plus n minus 1, then you close the bracket d. So we have proved that the sum of the arithmetic progression is equal to n divided by 2 all into 2a plus n minus 1 d, which is the same as that one. It is the same as that one. This is general. Let's make, for example, another example without using formula. Let's say that Sn is equal to 1. Let's put values now. 1, let's say the second term is 2 plus 3 plus 4. Let's end them. Let's just end them. And then you say the second principle, say that Sn, this equation is equal to the second equation, which is, we're going to start from there, coming back to 3, 2, 1. Therefore, I'm going to put 4 plus, then 4 plus 3 plus 2 plus 1. So we have to add equation 1 and equation 2. We have added equation 1 and equation 2, but on this we're going to add this and the equation 1 and equation 2 in equation 2. But now we have values. 1 plus 4 is equal to 5. 2 plus 3 is equal to 5. 3 plus 2 is equal to 5. 4 plus 1 is equal to 5. That equation means this thing. This equation means this thing, which means when you add the first term with the first term of the second equation, the first term with the first term of the second equation will give you the same answer will give you the same answer with the second equation, the second values when you add both second values, second terms, and in both equation. I think this is clear. Let's go to the next equation. The next question said that you have to calculate the value. Calculating the value of sum of 50 terms. Sum of 50 terms where k is equal to 1 and 100 minus 3k. We are determining the sum of the 50 terms. So we have to find first the first three terms. When you substitute 100 there, when you substitute in place of k, you substitute 1. First, you have to substitute 1 in place of k. Therefore, we're going to say 100 minus 3. Therefore, substitute 1. Therefore, it's going to give us 97. Therefore, the first term, the 97. The second term, then go and substitute in place of 1. 2. Substitute 2. Then the second term is 94. The third term, then go substitute 3. The third term is 91. Therefore 91 dot up until to the what? To the last term. The last term must be 50. Should be 50. The last term is 50. So substitute 50 in terms of k. In place of k, substitute 50 so that we can find the last term. To find the last term, therefore the last term is negative 50. It's negative 50. So to determine the sum of this series, you know that there is a constant difference of what? Of the 97 minus 94. 97 minus 94 is 3, then it's 3. There's a constant difference, which means we're going to use an arithmetic series. The sum of the arithmetic series. Which is Sn. Let's take this one. Sn is equal to n divided by 2. Therefore, first term plus the last term. Therefore, the number of 50 terms we divided by 2, all into the first term is 97 and the last term is what? Is 50. When you punch that in your calculator, say 50 divided by 2. 50 divided by 2 is 25. Therefore 25 all into 97 minus 50. 97 minus 50. Then it gives us 1175. Therefore, that is the sum of the 50th term of the 50 terms. So, if you don't want to use that formula, if you don't want to use this formula, you can use this formula. There's the one that we have proved above on question on 2.1. The one that we have proved on 2.1. This formula n is equal to 2a plus n minus 1 all into d. Just substitute all your values. You will see that you will find the same answer as this one, 1175. The next requirement, 2.3. The next requirement in 2.3, they say that we have to find a quadratic sequence. A quadratic sequence is defined with the following properties. T2 minus T1 is equal to 7. T3 minus T2 T2 is equal to 13, T4 minus T2 is equal to 19. Therefore, they asked you to determine T5 minus T4 in A, point A, T5 minus A. Therefore, let's go and try and 2.3.1. 2.3.1. We've given that they say that T2 minus T1 is equal to 7, and T2 and T3 minus T2 is equal to what? Is equal to 13. Therefore, and then T4 minus T3 is equal to what? Is equal to 19. Know that the first term T1 with the second term T2 with the third term T3 with T3 terms of the quadratic, and T4 and T4. We don't know these values. We don't know these values, but we know that there is a difference between these terms. These terms we have given the difference. When you say T1 minus T2, T2 minus T1, you find that difference, which is 7, and T3 minus T2, you find the difference of 13, and T4 minus T3, you find the difference of 19. So we have 7 and 13 and 19. 7, 13, 19. So they asked us to determine T5 minus T4. T5 minus T4. What is the difference? What is the difference between the T5 minus T4? T5 minus T4, let's add the T5. So we're trying to determine what? To determine this difference. This difference. Yeah, we don't know that difference. So we have to find the difference from this series, from this sequence. So 13 minus 7. 13 minus 7, we know that is 6. Then 19 minus 13, we know that is 6. To find the following value, 13 minus 6, or 7 plus 13, 7 plus 6 is equal to 13. 13 plus 6 is equal to 19. 19, so we have a constant difference, which means that the second difference is constant in quadratic equation. Therefore 19 minus 19 plus 6, 19 plus 6 is 25. Therefore 25. Therefore T5 minus T4, term 4 is equal to 25. Then you find your mark. This is A. I think this one is clear. Let's go to B. In B, they say that we have to find T70 minus T69. T70 minus T70 minus T69. Term 70 minus term 69. How did we find the term 70 minus term 69? We're determining the difference. The difference here, the first difference, we know that this first difference, the first difference here is what? Is arithmetic progression. Arithmetic progression, we know that it have a what? A constant difference. But we know the first difference must have a general formula of the arithmetic series, which means Tn is equal to A plus N plus 1D. So we're gonna find the difference between between the term 70 and 69 by using this general formula of the arithmetic progression. Let's start. Let's find first the general formula. General formula is Tn is equal to, let's substitute in place of A, substitute 7, because our first term in first difference is 7 plus all into n minus 1, this is n minus 1 here, n minus 1. The constant difference, say that the constant difference of this arithmetic progression is 6. Therefore, it's going to put 6 there. Therefore, Tn, or to determine, okay, we're determining the T70 minus T69. So to find the, okay, let's check our formula if our formula is correct. When we substitute in place of n, we substitute the first term to find this equation. When we substitute 1 there, 1 minus 1 is 0. 1 minus 1 is 0. Therefore, 6 times 0 is 0 plus 7. Then you find the first term. So, in place of n, you substitute the previous term, which means it is 69. And to find this value, in place of n, you're going to substitute the previous term, which is 2. So, in this problem, in this one, you're going to substitute 69. Therefore, 7 plus all into 69 minus 1, 6. Therefore, let's punch the calculator. Say that 7 plus all into 69 minus 1 all into 6. All into 6. Times that brackets by 6, then you got 415. Therefore, 415. Therefore, 415. Find that 415. Therefore, T70 minus T69 is equal to 415. Is equal to 415. I hope this one and also this one is clear. Let's go to the next question. Okay. In 2.3, they say that we have to calculate the value of the T69. Calculate the value of T69. If calculate the term of T69, determining T69, which means determining the term of the value of T69 there. That value, they want to know what that value of T69. So, if T89 is equal to 23,594, we have to use this value. They gave us for a reason. So let's solve it. Let's try to find the value of T69. To find T69, we're gonna say 23,594 minus all the previous sum from 69 to 89, all the previous differences from 69 to 89. So, which means say that we're gonna say T89. Term 89 that they give us minus the sum of all differences, the sum of all differences of all previous differences. Add the sum of all previous differences, then you subtract to that value of the 89th term. So the 89th term is 23,594 minus the sum. You know that first difference and in quadratic equation is the arithmetic progression. So we have to use the formula of the arithmetic progression, the sum, the series of the arithmetic progression, and divided by 2 all into first term plus the last term. Then we cross bracket. We close the bracket. So let's substitute 23,059 for minus all into n. How many terms from 69? We said that 69 to what? To 89. So we'll take a calculator. 69 minus 89. So you're determining the sum of the 20th term here, the sum of the 20th term, which means 20 divided by 2 all into the first term. We know that the first term, we say that from 69, the first term difference there is 214. Take that 214. 214 plus the last term. Determine the last term. How are we going to determine the last term? The last term of the arithmetic progression on first difference. Use the formula of the arithmetic progression, which is a plus n minus 1 d. We know that a is what? A, the first term was 7 plus the number of term up until to the last term up until to 89. Up until to 89, so we're not gonna substitute 89, gonna substitute what? 88. So 88 minus 1, the difference, we know that the difference, we've already calculated the difference on the first difference of the arithmetic progression, which is 6. So punch everything there, so that's 7 plus all into 88 minus 1, close the bracket, then close the bracket, then you times all by 6, then you got 529, therefore is 529, then you close the bracket. Therefore determining the T69, therefore T69 is equal to therefore 23,594 minus, let's punch everything for this one, is 20, which means 10 all into 214 plus 529. Then our solution is 7430. I think it's correct. 7430. Therefore, 7430, 23,594 minus 7430. And I'll say that minus 7430 is gonna be 16,604. I think this is the right answer, or this is the correct answer. Sorry. There's a mistake somewhere. This is not 240. We didn't find 214 on the previous question. We found we found 415. So there must be 415 there. 415. Then substitute. Just change here. 415. 415. Therefore, which means this answer will change. It's gonna change. So let's punch again. Sorry. So we're gonna 415 plus 529 times 10, which means it's gonna give us 944.0. Therefore, which means this answer will change. Therefore, T69 will be equal to therefore 20,000 minus 20,594 minus 9,440 minus 23,594, which means give us 14,154. Therefore, that's our final answer. I hope this is clear. This is clear. Just try and do and practice it and analyze it properly. You will find it correct. Just use your brain. Thanks. You will go and watch part 1 before and watch part 2. Then part 3 is coming tomorrow. Which is question 3 of this paper, Feb March 2015. So my name is Tamo Mfuneko. Morning, ladies and gentlemen. This question paper is adapted Feb March 2015. It was a sub. Okay, this is only question 1. Then we're solving for X question 1. Then it's out of 27 marks. The full question in 27 marks. So let's start. Okay. 1.1.1. We solve for x squared minus x minus 20 is equal to 0. This question is only 2 marks. So there's nothing much you're gonna do here. In the science alpha, we just factorize. This is trinomial, so we have to factorize and find the factors of this trinomial. Okay. The factors, I'm gonna find the factors of 20. Go to 20, find the factors of 20 is 5. It's 5 and 4. And then you check the coefficient of the first term. X is 1. Therefore, 1x squared. Therefore, x times x gonna give you x squared. 5 times 4 is gonna give you 20. And then you go and check the sign. You cross multiply both. 5 times x is gonna be 5x. 4 times x is gonna be 4x. Then you check the sign of the middle term, negative. Then you go and put next to the coefficient of x that have a bigger number. You go and put next to 5. Therefore, gonna be negative 5x. The sign in negative ungayitimes ngeyiphi sign ukuze ufumane the sign ne last term engu-negative. Ungayitimes ngantoni? Nge-positive. Positive times negative gives you negative. So then 4x minus 5x is negative x, which means our factors are correct. Then we have x minus 5 and x plus 4. Then x minus 5, x plus 4 is equal to 0. Therefore, x is equal to 5. Then you transpose x on that side, or x is equal to negative 4. Then you told 2 marks so easy. Go to question 2. Oh no, question 1, 1.1.2. You solve for x, but here you correct to 2 decimal places. It's obvious. You know that you're gonna use a quadratic equation, or if you don't use quadratic equation in this question, if you are good in differential square, you can solve x by using perfect differential square. Okay. Therefore, 2x squared minus 11x plus 7. Then you put your formula. It's easy peasy. 2x squared minus 11x plus 7. Then a is equal to 2, b is equal to negative 11, c is equal to 7. This is the formula. Then you substitute to the formula. Then you put negative. Then negative 11 plus or minus root negative 11 squared minus 4 all into 2 all into c 7 divided by 2x. Then you just punch your calculator. You punch everything, then it will give you the answer. Just try and find it to be sure. X is equal to 4.77 Remember, they said you have to correct to two decimal places. Gonna use positive first, or you can use negative first. But when it is negative, x will be 0.73 when you round out to two decimal places. Then you get your 3 marks, easy 3 marks. Then go to the next question. We have 5x squared plus 4 greater than 21x. This is an inequality. You know this is an inequality, so we have to solve for x using inequality. So, but this x we have to put in a standard form to make it a trinomial. To put in a standard form, gonna 5x, gonna say 5x squared minus 21x. You transpose that 21x, positive 21x, to the left hand side. It's gonna be negative 21x plus 4. This 4 is greater than what? Greater than 0. Then you find your factors. You factorize. Then 4, factorize 4. Factors of 4 is 2 times 2 and 4. 4 times 1 is 4. Then you go to the first term. The first term is 5x squared. When you say 5x times 5x squared, 5x is going to be 5x squared. Therefore, you cross to multiply 4 times 5x is going to be 20x. Then x times 1 you're going to be x. Don't put signs first. Just find the values. Let's go and check the sign of the middle term. The sign of the middle term is negative. Then you go and put in a bigger number. The coefficient of x that has a bigger number is 20. Therefore, we're going to put that negative next to 20. Therefore, what did we find? 20 is 4 times 5x. Then we're going to put negative there. There you go. Then the negative in x, the negative, times and negative because it's the sign of the last term and positive. Negative times a negative give us a positive. Therefore, that answer, that negative, going to put next to x. Therefore, to prove that if Ilandoza effect has it was correct, I say negative 20x minus x gives us negative 21x. Give us negative 21x. Therefore, our middle term is what? Is 21. Therefore, our factors are correct. Go and put your factors. X minus 4 all into x, 5x minus 1 greater than what? Greater than 0. Remember, these are inequalities. Then x is greater than 0. X minus 4 greater than 0, or 5x minus 1 greater than 0. Before you do this, before you find your solution, go and plot your graph. You have to show there's a mark for graph. There's a mark for graph. Then we have 4. Then you have 1 over 5. After you have transposed, you said x4 and x1 over 5. Then 4 and 1 over 5. Therefore, x is greater than 4 and x is less than half, which means that this form is when you go, if you're gonna put use a graph, this is a quadratic equation. This is a quadratic equation. This is a quadratic equation. So it must be you shape, like you use that shape of a quadratic, of a parabola. Parabola, it's upward. So x is equal to any value, which means that you are finding the domain. It's like you are determining the domain. X greater than any value greater than 4 and x less than negative 1 over 5, which means that when you're finding a domain for a graph, say that you're saying that negative infinite of a parabola, negative infinite to positive infinite. That is the domain of this graph. So it's clear. Therefore, say x is greater than 4, or x is less than, x is less than 1. Therefore, x is greater than 4, or x is less than 1 over 5. Then you get your 5 marks. Then go to the next question. go to the next question. He's saying that we have to solve. We're still solving for x. It's 2x squared, 2 to the power 2x minus 6 times 2x is equal to 16. Therefore, 2 to the power 2x minus 6 times 2 to the power x is equal to 2 to the power 4. You can simplify that 16, but there's no mark for that. You simplify that 15, break down to the simplest form. It's going to be 2 to the power 4. 2 to the power 4 is 16. Therefore, it's 2 to the power x minus 6 times 2 to the power x minus 16 is the same. There's nothing you've done here. You will not get marks. You are still writing. You are still simplifying the equation. Still the same. There's no mark up until here. Then it's equal to 0. Then you factorize. You see, you have to factorize this, but it is in the form of a trinomial because the first term have x and the second term have x. The last term is constant. Is a constant. Therefore, you have to factorize. When you're factorizing this equation, this equation, gonna say find 2 to the power x. 2x times 2x is gonna give us 2 to the power 2x, not 2 to the power 2x squared. You don't do that. It's gonna be 2 times 2. It's going to be 2x squared minus 8, minus 8 all into 2 to the power x plus 2 is equal to 0. Therefore, then 2, then you break 8 to 2 to the power 3. Then 8 is going to be 2 to the power 3. You transpose on this side, that this will be positive. Or 2 to the power x plus 2, then you transpose 2 on that side to be negative. Then to the 2 to the power x is equal to negative 2. Therefore, no, that just cancel this. Therefore, x is equal to 3 or 2x. There's no solution for this. You can't do anything to this. 2 to the power x is equal to negative 2. You can't do anything. You can't even simplify negative 2. When you say negative 2, you can't even simplify. Therefore, 2 to the power x is not equal to negative 2. Is not equal to. There's no solution. No solution for this. Therefore, find your full 4 marks. Then go to solve for x. We solve for x and y. Solve for x and y. 1 plus y plus 1 is equal to 2x. Then x squared minus xy plus y squared is equal to 7. Then you solve for x and y. You have your equation 1 and you have your equation 2. Therefore, try and find equation 3. How will you get equation 3? You will get by solving any variable between the two equations. It's either you choose this or you choose this. But me, I chose equation 1 and make equation 3. So I solve for y. Y is equal to 2x. Then I transpose 1 on that side to be negative 1. That's my equation 3. That's my equation 3. Therefore, you substitute equation 3 into equation 2. This equation into this equation. In place of y, you're going to put 2x minus 1. 2x minus 1. Therefore, x squared, put that x squared. That's x squared minus that x minus x all into, then we found y. That y will be replaced by 2x minus 1. Therefore, 2x minus 1 plus y. Then we found our y. Then you're going to replace by 2x minus 1. Then 2x minus 1 squared. Don't forget to put squared there. Is equal to 7. Therefore, you simplify the equation. You simplify this this equation. X squared minus, then you open the bracket by x. Negative x times 2x is gonna be negative 2x. Therefore, negative x times negative 1 is gonna be positive x. That positive sign plus. Then you know this 2x minus 1 is in two brackets. 2x minus 1 and 2x minus 1 and 2x minus 1. When you times the two brackets, 2x minus 1 will give you 4x squared minus 4x plus 1. Therefore, is equal to 7. And then you simplify again, you collect the like terms. We're going to say x squared minus 2x is negative x minus negative x plus 4x going to give us 3x squared. Go to the x's. X minus 4x is going to give us negative 3x. Therefore, you transpose that 7 on this side. 7 going to be negative on this side. 1 minus 7 going to give us negative 6 is equal to what? Is equal to 0. Therefore, awunokwazi like solver, you factorize this equation without dividing. Look the coefficient first. Let's check the coefficient of the first term, then ujonge ukuthi iyangena kuzo zonke na eza terms zilandelayo. Therefore, we have to divide by what? By 3, because the term the coefficient ka x squared ilapha eqaleni iyakwazi ukungena pha. So let's simplify our equation, our quadratic, our trinomial. Let's simplify our trinomial. When you simplify this trinomial, you're going to divide by 3, divided by 3, divided by 3. So how many 3 goes to 1 is how many 3 goes to 3 is 1, therefore x squared. Then cancel this 3 to 3, then 3 we hang up, then it's going to negative x, then negative 2x is equal to 0. Then we find the factors, factorize. You see, we always factorize. So when you find the factors, check the factors that side. We have 2, we have 1, 2 times 1 is going to give us 2. X times x is going to give us x squared. Therefore, we'll cross multiply before we put the sign between those, between the number these values. Then 2 times x is going to be 2x. 1 times x is going to be x. Thirdly, go and check the sign of the middle term and go and put next to the coefficient of x that have a bigger number. We have an x, negative. Then go and put next to 2. Because 2 is the bigger number, then negative 2. That negative 2 was only times an sign. Which sign you're going to use to times this negative 2 so that you can get another negative. So you know that when you times a negative by positive, you get another negative. That positive put next to positive x. So negative put next to 2, then positive next to 1. Therefore you cross multiply. But when you finalizing, when you try and find the solution for this negative 2x plus x, you take the sign of a bigger number, then you subtract, then it's going to be negative x. Therefore, negative x is negative x. So our factors are correct. Our factors are correct. Therefore, put our factors x minus 2, x plus 1 is equal to 0. Then you solve for x. Transpose 2 on that side. Going to be positive, x is equal to 2 or x is equal to negative 1. We're done with x, so we have to find what? We have to find y. Substitute all the values of x into equation what? Into equation 3. You substitute all the values of x into equation 3. So we take that equation, y is equal to 2x minus 1. Y is equal to 2 all into, substitute the first value, 2 minus 1. Then when you simplify this, we're going to get 3, or y is equal to 2. Then you substitute negative 1 on this, negative 1. Therefore 2 all into negative 1. In place of x, you put negative 1 minus 1. Then we're going to find your answer is B, negative 3. Simple. Then your solution set. Then x was 2 when y was 3. Therefore negative 1 when y is negative 3. Then you find you got your 6 marks. Fake poko twin. 1 minimum marks. It's easy. Now go to the tricky questions. This question, the previous one was easy. Let's go to 1.3. 1.3. to have the root of the quadratic equation are given by x is equal to -6. This is -5, sorry. This is -5 plus or minus 20 plus 8k divided by what? Divided by 6. So, okay. You see this? This is in quadratic form. The quadratic equation, you know the quadratic equation, this is b, and there's a and c, then 2a, yeah, 2a, okay. Where k element, -3 is -2, -1, 0, 1, 2, 3. You see, the k it range between these values. K is between these values. Okay, so 1.3.1, the requirement is that they say write down two values of k for which the root will be rational. For which values of k will be rational. This is not a tricky question. This question is easy. You take you take that root. You see the root 20 plus 8. Take that root. This is a discriminant. When you take that root only, it's a discriminant. We call that a discriminant. So you substitute in place of k first. Substitute to -3, but to be rational, any values I substitute up. But the solution of the root, when you say root 20 plus 8 and that value you have chosen, it must give us a valid answer, not like it's like a negative value. It must give a positive value, and the value equals uphuma ku square. Not if values are undefined. If that value is undefined, when you substitute endaweni ka k, it's non-real. It's non-rational. In other words, so let's start. Use -3. When you say -3, substitute in place of k. -3. Substitute in place of k. You're gonna say root. Therefore, have 20. Sorry, 20. Say 20. Plus 8. Start from -3, then -3. -3. This one is undefined. There's no solution for this. Therefore, we don't want -3. -3 is out. -3 is out. So it's not our solution for this problem. We want something that is rational. When classicity square root is ophuma ku square root low answer, low value. So let's go to -2. -2. The root 20 plus 8 -2 is equal to 2. Therefore, our ilanduza yethu, like the value, this value, the final value, the sum here ilanduza the root iphumile, which means it was 2 here. It was 4. Therefore, root 4. When you say 20 plus 8 times -2, 20 minus 16 is 4. Root 4 is equal to -2. Therefore, that value is rational because it's positive, and futhi ikwazi ukuthi ukuphuma kwentoni ku square root, which means it is rational. K is equal to 2. Then we find the values, not value. So you also phelela kula k is equal to 2. So this one is correct. This one is correct. It is rational. Let's start at -2. So substitute in place of what? Of k. So let's continue. Go to -1. -1. Oh, sorry. -1. Therefore, -1. -1 is not a perfect square. It's not a perfect square. It is in decimal, so it is not rational. It must be a perfect square. A perfect square, you know that, is something that when you rotisha lando, it can get the whole number. The whole number, not the number ezoba decimal form. So this one is not correct. negative 1. Go to 0. When 0, 8 times 0 there, it's going to be 20. Root 20. When you put 0, pi is 1 with 0, plus 1, plus 20. So to root 20 plus 0. Root 20 plus 0 is 1 some comma something. So lendo in decimal form is not rational. It's not rational. So 0 also go to 1. Substitute 1, positive 1 on this time. Then 8 times 1 is 8. Then root 28. Yamazi root 28 akaphum root 28. Root 28 uzoba in decimal form. Root 28, you see, is in decimal form. So it is not rational. Go to 2. Substitute 2. It's fine. Substitute 2. 20 plus 8 all into 2. So abasho. So with 6 can go. With 6. So which means it was a perfect square. Perfect square equals on the root. So the sum of those values was perfect square. Root, which means it is what? It is rational. Therefore, going right again, k is equal to 2. Towards k is equal to negative 3. Okay. Then and try and substitute 3. You will see that it will give us a negative value. It will be undefined when you substitute 3 in place of k. So this is our solution. K is equal to 2, or k is equal to negative 2. That is 2 marks. You have to think fast when you answer this question. Okay, this question. Write down one value of k for which the root will be non-real. Solution. Non-real. Yes, I told you about non-real. Non-real is something like non-rational. Non-rational, which means the discriminant. Discriminant is less than 0, which means this discriminant. I said this root 20 root something is a discriminant. It is less than what? It is less than 0. And when it is less than 0, which means any value, like 20 plus it's even negative sum. When it gives us a negative sum, that value when you root, rotation is over undefined. And even when you punch your calculator, you will not get the answer. So when you substitute negative 3 in place of what? In place of k on your discriminant. When substitute negative 3 on a discriminant, substitute negative 3 here. You have negative 3. You will see that you will not get the answer for this. You find undefined value. Let's check this. Let's check. Then 20 plus is plus now. 20 plus 8 all into negative 3 all into, close the brackets. Then there's no solution. Math error. Therefore, there's no solution for that. Therefore, which means it is non-real. It is non-rational. Non-real. Therefore, k is equal to 3. They said, write down one value. Start from here. There's no need to check other values. If you found one value, you already found one value. So you don't have to check negative 2, negative 1, 0, 1, 2, 3. You're wasting time. Negative 3 is the first value, right? K is equal to negative 3. Then you find 1 mark. I think, Then you find 1 mark. I think it's clear now. Okay. They're saying that calculate A and B. Be careful about this question. A and B all root. If all root 7 to the power 2014 minus 7 to the power 2012 divided by 12 is equal to A, or 7 to the power what? To the power B. To the power 7 to the power B. Sorry, this is B. This is B. 7 to the power B. 7 to the power B. Okay, and A is not a multiple of 7. A is not a multiple of 7. That value there, because if you A, might be multiple of 7. You know the multiples of 7. You know the multiples of 7. If it's a multiple of 7, your answer is wrong. So, what will you do? We're going to simplify this thing. We have to first to simplify 7 to the power 2014 minus 7 to the power 2012. Therefore, you have a common factor then. That put 7. 7 is a common factor, but put outside the brackets before you use the powers. Okay, we have 2014 and 2012. Okay, 2014 and 2012, we have two difference there. We have a difference of 2 there. And so we're gonna take out 7 to the power 2012 as our what? As our common factor. All into 7 to the power 2012 as our common factor. All into 7. All into 7 to the power 2. You know that when you say that 2 to the power 2 plus 2012 is osnikaban 2014, then minus, then 7 to the power 2012 is already outside. So 7 to the power 2012 times negative 1 is going to give us 7, negative 7 to the power 2012 divided by 12. Well, it's clear, no? I think so. It's clear, the step. Then go to this step. The following step, you know, Sayenza, just simplify this thing. Open the brackets, you know, it's mathematical. Mathematically, you open the brackets before you do anything. Open that bracket with 7 to the power 2 minus 1. Able, just simplify. Therefore, when I times 7 squared minus 1, no, 7 squared umbani, 49. Therefore, minus 1, 49 minus 1 is going to give us 48. And therefore, 7 to the power 2012 times 48 divided by 12. Ungalibali or root. Umbeke or koko. Therefore, uzothi ke ngokuzihlobo zam. You see this 12. Buzela nje. Kuthi lo 12. Uya kangaphi pha? Uya kangaphi? Pha ku 7 to the power 2012 times by 48. Ku 48 uya ngaphi? Uya kai 4. So you put your solution 4. Then 7 to the power 2012 times 4. That's your answer. I think it's clear. 12, how many 48 or 12 babanga par 48 by 4. Therefore 7 to the power 2012 times 4. Or root, ayikaphumi root. Then you root ke ngoku, ane? Ibase yakho i-root ka 4 ngubani? Ngu2. I-root ka 7 to the power 2012 ngubani? U7 is not root, just root the square, the power. U7 to the power 2012, 7 to the power 2012 uzongubani? Uzoba ngu 1006. Let's see. Okay, let me 7 power 2012. 7 to the power 2012. Amen. Ish. But you punch 7 to the power 2012. 7 to the power 2012. 7 power 2012. I'm not used to this calculator, man. Simple financial calculator. Hey, what I'm doing now? 7 to the power 2012. That's how I go for it. 2012. 7 to the power 2012 is 1. 7 to the power 2012, 106. But it's 106. 106, therefore, is equal to A. You see now, that standard form. That standard form is A all into 7 to the power B. You see? So yes, already there will be 7. That's just put la 7 when make la 7. Then U P is over 1006. A is 2. but a must not be multiple of what? Of 7. Therefore, a is equal to 2. A is equal to 2. I think this is the final answer. This is the last question. So if you don't understand any part, please ask me a question. Ask if you don't understand. 27 marks though. You have to more than 27 marks. And go to question 2. Question 2 is patterns, and question 3 is patterns. And more that 20 something, 24, let's say it's estimated to 24, 25. Then question 4, question 5, it's functions. Then but these first question 1, 2, 3, more them. Yeah, thanks.